In this chapter, we are going to discuss about how a computer network works. It is very essential for a network engineer to understand the basic principle of the computer network. If you are a network engineer, you must learn how a computer network actually works. And without knowing this, you won't be able to design a network or troubleshoot a network problem. So in this chapter, we are going to discuss about the working principles of a computer network. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, chapter number 24, How a Computer Network Works. In this chapter, we will discuss about how a computer network actually works. This is James. James is a smart boy who is interested in video games. He wanted to get a video gaming console for the school vacation. So he went to Mr. Martin, who was running a video gaming console shop. Martin is a seller of video games and his shop contained different types of video gaming console. So James went to the store and he chose a video gaming console as per his budget, which cost $100. After the selection, he went to the cash counter to pay the bill. So Martin received $100 from James and he registered the sale and generated the invoice and give it to James. Now James is the owner of his favorite video gaming console. Now let's come back to Mr. Martin and his video gaming store. His shop is one of the best shop in the neighborhood. He is running this business several years. His shop contains different model of video gaming consoles, which is so much demanded in that area. He has a sale counter to record all the sales. So same like James, there may be hundred of other people are coming to Mr. Martin's store to purchase the video gaming console. So how Martin can record the sales of his store and how much money he made from the sales of the video gaming console. And you know Mr. Martin is very clever and he is using the latest technology. He is using a computer application in his store to register all the sales happening in that store. Since he is using a computer application to register the sale electronically, he wants a place to store all this information. For that, he is using an application server which is running a sales application and it is talking to the sale counter PC. Each entry making in the sale counter PC that is sent into this application server and it's stored in its database. So whenever Mr. Martin want to get some information about the sales report, like how much sale done in a day, weekly, monthly, yearly, he can retrieve the data from the application server so easily. So here the application server also need to communicate with the Martin sales counter PC. So by implementing this computer, server and network infrastructure, Martin can get all the detail about the sale in his fingertips so easily. Now let's see how Martin set up his network infrastructure for hosting the sales application. So this is the network infrastructure setup created by Martin. On the left side, this is the store network, which contain a cash register PC, a network switch, and a router. On the right side, this is the data center network, which contain the server, a network switch, and a router. So here, why Martin hosts the server in a data center? Why he couldn't put the server in his store itself? Because the server is very critical. It is running his sales application and it should be available all the time 24/7 without any interruption. The server need uninterrupted power supply and the best cooling system to cool down the server temperature. A place like store where all the customers are coming day by day, that is not a good idea to store a server. So that's why Martin hosts the server in a dedicated data center. Maybe this data center is at nearby building, or maybe it is too far from the store, or maybe even it is hosted in any other country. So from this network infrastructure, we can say that there is no direct interaction between the store network and the data center network. Store's network stay at the store and the data center network, it is at the data center. So how the network communication happening between the store network and the data center network? So here you can see another network which contain a single router here. That is the service provider network. Or it is in another private network. So this network helps to communicate between the store network and the data center network. So any traffic coming from the store and going to the data center and vice versa, they must pass through the service provider network. So this is the setup of Martin network infrastructure. Now let's discuss about how a network works in a real world. Here we are using the OSI model to explain the working principle of a network. OSI stands for Open System Interconnect. It is a logical concept that used to explain the working principle of a network. The OSI model has 7 layers. Starting from the bottom, layer number 1 is the physical layer, layer number 2 is the data link layer, layer number 3 is network layer, layer number 4 is transport layer, layer number 5 is session layer, layer number 6 is presentation layer, and layer number 7 is application layer. So in OSI model, each layer has its own function to perform in a network communication. Here we are going to discuss about the function of each layer and how it is helping in a network. OSI model uses a vertical approach toward the network communication. It is either from the top to bottom or from the bottom to top. Depends on the sender and receiver parameter. Now let's discuss about the functions of each layer and understand how they are helping in the network communication. Let's start from the top layer, that is the application layer. So what is the function of the application layer? The main function of the application layer is to help the application to communicate with the network. So the application layer is used by the end user software which is running in the computer. They are using some kind of application layer protocols, and this protocol help the application to communicate with the network. Here let's take the example of this computer. This is the computer attached at the billing counter of the Martin store, and it is attached with a cash register. So this computer is running an application. This is the sales application used to register the sale. So this application will generate some data, and that data need to send to the network, to the destination. So how this data going through the network? That is with the help of application layer. Application layer help this computer application to communicate with the network. So this computer application send the data to the network. This is the function of the application layer. Now let's go to the next layer, that is the presentation layer. So what is the function of presentation layer? The function of presentation layer is to convert the data into a generic format so that the destination device can easily understand and read the data. So here why we want to convert the data into a generic format? I will tell you why. This computer application is running at the billing desk PC. So this application may be developed or coded in a specific language, which can be HTTP or HTTPS or C++ or Java, etc. in any kind of computer language. On the other side, the destination device, that is this server, maybe that application, the server application, maybe it is running the ASP.NET or VB.NET or any other kind of language. So here both sides are using different kind of language in the application. It is not necessary that both sides must be used the same language. So in this situation, how this server application can read the data that is sent by the client PC, because it is sending data in a different language. In the same way, when server send a data back to the client machine, how it can understand the language that server is speaking? It may be a different language. So in this situation, the data must be converted into a generic format so that all the device in that network can understand and read the data so easily. So this is the function of the presentation layer. Presentation layer convert the data that is sent by the client PC into a generic format, and that format is sent to the server side. So since it is in a general format, the server can easily understand the data very well. So this is the one of the function of the presentation layer. Another function of presentation layer is encryption. So what is this encryption? Just imagine the client PC is sending some critical data to the server, which may be the credit card detail of the buyer or the customer address or any other kind of valuable information that need to be protected by the privacy. So when the client PC send the data over the network, what if some evil person in between sit and steal this data? It steal the data and read the data and understand what is the content. And this information this evil person can misuse. Maybe he can use that credit card information to do some online purchase, or he can use the ID information for the forgery. Lot of things he can do. So how we can protect our data in a network? So here we can protect our data in a network by using the encryption. So what is the encryption? Encryption means hashing the data with some additional information and convert that into a secret code. So when the encrypted data sent over the network, no one can read it, even they can steal it. If they want to open, they need to use a decrypting key to open the data and to read the data. So this is the process of encryption. Okay, now the client PC send the encrypted data to all the way to the server. So how the server can read that encrypted data? Here is the concept of decrypting the data. Decryption is the opposite process of encryption. In encryption, we used to convert the data into a secret format by hashing some additional key. And the decryption is the process of converting that secret data into a readable format. So at the server side, server decrypt the data and convert into the normal data that is in a readable format. So how the server is going to decrypt the data? By using a decryption key. So in the encryption, we have added some extra hashing bits to the data and converted into a secret format. So in the same way, at the server side, server is using another hashing method to decrypt the data. So this communication is secured between the client PC and the server itself. So whoever trying to steal the data over the network, they cannot read the data and they cannot use the data. So this is the function of the presentation layer. Now let's go to the next layer, that is the session layer. What is the function of session layer? The function of session layer is to start and end the session. So what is a session? Just imagine this server is a file server. It stores the file here. So our PC, which is located at the billing desk, want to access some file from the server. So PC send a request to the server, "Hi buddy, I need this file." So the server respond, "Okay, I have verified your access to that file. I am sending you that file to you." So the client PC receive that file and this communication ends. So this is what we called a session. This session include the request sent by the client PC to the server for the file. It also include the server response to the client PC along with the data. So this is what I called session. So who is managing this session between the client PC and the server? That is the session layer. The session layer start when there is a request from any network device, and the session layer end when the request is completed. So this is the function of the session layer in OSI model. So we were talking about the application layer, presentation layer and session layer. The first three layers of the OSI model from the top. These are the area in a OSI model that a network engineer doesn't have any control over it, because these three layers is a part of the operating system or the application itself. Basically, we can say that this layer function is completely managed by the application or the operating system of the computer. Now let's go to the next layer, that is the transport layer. So what is the function of a transport layer? And before we start, I would like to tell you, transport layer is the first layer where a network engineer is actually involved. Yes, the function of a network engineer is getting started with the transport layer. So what is the function of the transport layer? And before we start talking about the transport layer, we need to talk about the transportation. So what does the transportation mean? Transportation mean moving something from one location to another location. It may be a human, it may be an object, it may be anything. Its function is take something from somewhere and send to somewhere or carry to somewhere. For example, James is living in a village and he has one big container of apple. He wants to send this apple to his uncle who is living in town, and there are 100 kilometers in between his village and the town. So how James can send these apples to his uncle? He can use multiple transportation option. Maybe he can use a cycle to send this apple, or he can send this apple in a bus, or he can send the apple by car, or he can send this apple buy a sports car. So what is the difference of this multiple transportation option? Here, whatever the transportation method, this container of apple need to travel around 100 kilometer. So if we are using the cycle, what will happen? Maybe it take 6 to 7 hours to reach the destination. What if we going to send these apples using the bus? Bus is a heavy vehicle and it is not allowed to run in higher speed. So maybe this bus will take 2 to 3 hours. Now if he is going to send by normal car, it can reach in 1 hour because car is a small vehicle and it can run very faster than the bus. So in an ultimate way, if we can use the sports car which is running 180 km per speed, maybe he can send this apple in 20 to 30 minutes. So here, which transportation method he can use? He need to use the transportation method as per his requirement. If his requirement is save the cost but time is not a matter, then he can use the cycle. Or if his requirement is cost is nothing to worry but the time is important, then he can use this option, the sports car. So depends on the requirement. Here James can select the transportation method. Now let's come back to our network. Just imagine this container of apple is our data that we want to send to the destination over the network. So same like we use the cycle, bus, car and sports car, there are multiple transportation methods that we can use in a network. They are called transportation protocol. There are many transportation protocol we can use in a computer network. Which transportation protocol we will use? It is up to our requirement, how we want to send the data. We want to send the data in fast way or we want to send the data in a reliable way. So depends on the data communication method that demand by the application, a specific transportation protocol is being selected in transport layer. Mostly there is two protocol used by the transport layer. They are TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. So what is the difference between TCP and UDP? TCP is a very reliable protocol. That means if a sender sends data to the destination, it can assure that the data is received at the destination without any data loss. On the other hand, UDP is a non-reliable protocol. It sends the data in real-time method and there is no guarantee assured the data will reach at the destination. There is a possibility of data loss. And when we compare together, UDP is very fast and TCP is little slower than the UDP. But the main concept is TCP is a reliable protocol and UDP is a non-reliable protocol. So since TCP is a reliable protocol, why everyone cannot use the TCP? Why there is a requirement of UDP? Because there are some kind of requirement that we must need non-reliable and faster protocol like UDP. For example, voice over IP, video streaming, online gaming streaming, etc. These kind of requirement give importance to the fast delivery in real-time basis. It is not necessary that it has to be reliable because in all this requirement, the real-time communication is important. For example, if you are speaking to someone over the phone, whatever you say, that has to deliver to the person in real-time basis. If your voice data retransmit after 5 minutes, then the receiver is not going to get that message properly because that time is passed. So in this kind of application, UDP is mostly using and all other application TCP is using. We can say that 99.99% of application are using TCP. It is not only TCP and UDP used in transport layer. There are many other protocols also using, but this TCP and UDP are most popular one and mostly used in the computer networks. So one of the feature we talk about the transport layer is transport layer helps the data to transport from one location to another location, mostly from sender side to receiver side with the help of transportation protocol like TCP and UDP. Now the second function of the transport layer, segregating the service using the port number. So what is the port number and why we want to segregate the services based on the port number? Let's come back to our client PC, which is running a client version of sales application, and this is the server that is running server version of the client application. So here this is the PC that is using at the billing desk. There may be more than one cashier available in that store and there may be using this PC for multiple purposes. They are not only using this client sales application, maybe they are using this PC for web browsing. So they open a web browser, maybe the Chrome or Mozilla, and using for web browser. Or maybe they are playing an online game, or maybe watching a movie over internet. So all of this process is happening in the same computer, and all of this process is going through the internet or the network. So how this computer know the traffic's going from me? It is going from the web browser, or it is going from the online game, or it is going from the movie page that I am watching. Or how the PC know the incoming connection? For example, it is receiving the data from the internet or through the network. So that data belongs to which service that he is using. Is that data going to my web browser, or is the data going to my online gaming page, or is the data going to my movie streaming page? So how this client PC can differentiate the data going out and going in? That is with the help of port number. So in this port number, a specific port is applied to a specific service. For example, if the client PC is using web browser, then we can assign the port number 80 for that web browser, and the online game can be used 3000, and the movie streaming can be used 3600. So when we assign a specific port to that service, for every data incoming and outgoing can be tracked. This is the same case of the server also. Here we know the server sales application is hosted in the server, so it need a specific port. So let's give the port number 443 to the application. So maybe this server is not only hosted the sales application, maybe it is working as a web server. So the web server is running at port number 80, and maybe this server is using to stream an online video at port number 1800. So when the server receive a data towards the port number 80, it can understand that that data is going to its web server service. In the same way, when the server receive the data to the port number 443, it can understand this data belongs to the sales application. Same way, port number 1800 receive a data, it can understand that is for the video streaming application. So in this way, each service is separated by a port number, so that the source and destination devices can understand this data is coming from where and it is going to where. Even those devices try to respond to the request, it know to which port it need to send the data. For example, if the server receive the traffic to sales application 443 from the source port 5000 from this PC, it know the traffic came from the port number 5000. So when the server send the response to that query, it can send the data to the port number 5000 to the destination, that is the client machine. So these are the two major functions of the transport layer. One is using the transport protocol for the network communication, and another one is separate the services based on the port number. Now let's go to the next layer, that is the network layer. What is the function of the network layer? The main function of the network layer is to manage the logical addressing part of the computer network. The logical address is also called the IP address. So what is an IP address? IP address is the logical address that we provide to each device in a network for their identification. And this network layer is one of the layer that a network engineer has the complete control over it. So we already talked about the first three layer in the OSI model. That doesn't have any control from a network engineer. It is completely managed by the application and operating system of the computer. Then we talk about the transport layer. In the transport layer, the network engineer is partially involved because the remaining part is managed by the software developer or the application owner. Now network layer is the one of the layer that a network engineer has the complete control it. He can decide the network, he can decide the IP address, he can decide the subnet mask, he can decide the default gateway, everything himself. Now when we talk about the IP addressing of this network, we can say this is the store network, which is included a computer, cache register, one network switch and one network router. Then right side we have the data center network, which is include a server, a network switch and a router. Then we have the service provider network, which contain a router. Here we use only one router for the explanation, but maybe the service provider network contain multiple routers, hundreds of routers, thousands of routers. So here we need to provide the IP address to each network and each networking devices. So as a network engineer for the store network, I have provided the IP address 10.1.1.0/24. This is a class C IP address, and I have given the IP address 10.1.1.50/24 to the client PC, and I have given the default gateway 10.1.1.1 at one of the interface of the router. The other interface of the router is connected to the service provider network in this way. On the other side, at data center network, I have given 10.1.50.0/24 network, and I have assigned the IP address 10.1.50.100/24 to the server, and 10.1.50.1 is the default gateway. In service provider network, sometimes it is managed by the service provider, or sometimes customer can decide the network. So here I have given the network 10.1.2.0/24, one side of the router, and the other side of the router 10.1.3.0/24, and these are the IP address of the router 3. So all of this IP address and network address is designed, decided and implemented by the network engineer, that is you and me. We have the full control over the IP address in a network communication. So this is the function of the network layer. Now let's go to the next layer, that is the data link layer. What is the function of the data link layer? The function of data link layer is manage the physical addressing of the network devices. So what is the physical address? Physical address means the MAC address. MAC stands for Media Access Control Address. So what is this MAC address? MAC address is some specific kind of address that is integrated with the interface of the network devices when the manufacturer create the device. So we know this is the client PC, and one network port is connected to the interface of the client PC, the LAN interface. That LAN interface has a specific MAC address. Now in the case of this switch, maybe this is a 16 port switch or 24 port switch. So each interface of this switch has its own MAC address. Same applicable with the router also. This router has two interfaces. Each interface has its own MAC address. In the same way, all the devices, whether it is server, switch, router, every device in a network has their own MAC address. This is provided by the manufacturer. This is something integrated with the electronic chip, so we cannot change the MAC address of a network device in normal circumstances. So the data link layer manages the physical addressing part of the network. It also helps to transmit the data without any error by using its error correction technology. Now let's go to the physical layer of the OSI model. So what is the function of the physical layer of the OSI model? Physical layer functionality is to provide the physical connectivity to the network devices. It is so simple. We have a client PC here, we have a switch here, we have a router here, and here we have server and other switch, router. So how these devices are connected? These devices are connected with the help of cables. So this is the cable, this is the cable, these all are cable. So provide the connectivity between the devices in a network is the primary function of the physical layer. And when we talk about the connectivity, it may be a physical connection or a wireless connection. It doesn't matter. The connectivity between the devices is managed by the physical layer. Mostly we are using the copper cable or fiber optic cable in the physical connectivity model, and we are using the wireless in the wireless model. So this is the function of the bottommost layer of the OSI model. So here we already talk about the functions of each layer in the OSI model. Now let's see how this is applicable in a real-time network communication. We started this chapter with James. James wanted to buy a video gaming console. For that, he went to the Martin store. He selected the video gaming console as per his budget, which cost $100. Now James went to the billing counter for the payment. So the billing staff opened the sales application which is running that billing computer. He accepted the $100 from the James and started creating a sales order. So what is this sales order contain? This sales order contain the details about the product that they are going to sell. What is the model number? What is the product ID? What is the serial number? What is the cost of that item? Who is going to buy it? Means what is the information about the customer? What kind of payment method he will be using to pay the bill? Is it by credit card or is it by ready cash? All this kind of information. And this sales application create the data accordingly. So this data contain all this information. So this is the data created by the sales application, and this is the data it need to send to the server which is running the server application. So here we can say the data is ready. The application layer helps here to send the data over the network, and the presentation layer convert this data into a generic format, and it also encrypt the data for a secure transfer. Then we go to the session layer. Session layer start the session because this PC need to send the data to the server which is located in the data center network. For that it need to start a session. So session layer start the session. Now here is the transport layer comes into the action. So what is the function of the transport layer? Transport layer choose the transport protocol, whether it is TCP or UDP. So here we are going to use the TCP for the communication. So why we want to use the TCP? Because of its reliability. We need to make sure the data sent to the server receive it and register the sale in the server application. So we cannot afford data loss here. That's why we are using the TCP. So who is deciding which protocol need to be used in the transport layer? It is decided by the software developer or the application owner who create the application. He decide which protocol need to be used. He also decide which port need to be assigned to the application. Here we can see the application is running in the server on port number 443. This is decided by the application developer. He configure the client application in a way that all the data it must send to the port number 443. So in the transport layer, there are two more parameter will be added to the data. That is the destination port and source port. Here destination port is 443, which is decided by the application developer, and source port is 5000. So who is deciding the source port? The source port is decided by the operating system of the client PC. This number 5000 is randomly selected. It is not necessary that it need to be 5000 all the time. Maybe it is 5500, 6000, depends on the random selection of the client machine operating system. Now let's go to the network layer. The network layer manage the IP addressing part. So here two more additional parameter will be added to the data. They are destination IP address and source IP address. So what is this destination IP address? Destination IP address is the IP address of the server, the destination, and the source IP is the IP address of the client PC. This is decided by the network engineer, and also it is written in the application itself. Any data that is sending to the server application, it must send to the destination IP address 10.1.50.100. Now let's go to the data link layer. In the data link layer, two more parameter will be added along with the data. They are the destination MAC address and the source MAC address. So which destination MAC address we will be using here, and what will be the source MAC address? We know the source MAC address is always from the source. So here the source is this client PC. So this is the source MAC address. And what is the destination MAC address? Is that destination MAC address means the MAC address of the server? No. In this stage, it is not the MAC address of the server. Then which MAC address it is? To understand which MAC address it is, we need to understand the data transfer process. So for that, we know the data is ready in the client PC. And along with the data, the destination port and source port is already added. So this computer know this destination is going to port number 443 and the source port is 5000. And again in the network layer, the destination IP address and source IP address is added along with the data. So this computer who is sending the data, it also know the data is going to the destination 10.1.50.100 and the source IP is 10.1.1.50, that is the IP address of this PC itself. Now this computer send the data to this destination 10.1.50.100. First of all, from the PC, that data is going to the network switch. So what is happening in the network switch? Network switch is a device that helps to implement the network communication between the multiple devices. Each network device we are going to plug into the network switch. So there is a functionality in the network switch which is called MAC address table. It is also called CAM table, that is stands for content accessible memory table. So what is this MAC address table mean? So MAC address table is a table that is stored in the switch memory. And what is its content? It contain all the device MAC address and associated network port that device is connected. For example, now this PC is connected to at port number 1. So in the MAC address table of the switch will be written the interface number 1 is connected the device PC and its MAC address is this one. So for each connected device, switch maintain a table along with its MAC address and interface number so that it can easily understand which device is connected in which interface. So when switch receive a traffic, it can look the MAC address and forward the traffic into that port without affecting the other network port. Switch is also using another concept called ARP. ARP stands for Address Resolution Protocol. So what is the function of this protocol? This protocol helps to bind a MAC address into an IP address. We know that the switch store the MAC address of every device that is connected to it in its MAC address table, and with the help of ARP, that each MAC address is converted into its specific IP address. So by identifying a MAC address, switch can identify its IP address also with the help of Address Resolution Protocol. So here, when the switch receives the data that is pointing to the 10.1.50.100, this destination, switch look into the MAC address and the ARP binding and see is there is any device in the IP address of 10.1.50.100. Switch cannot find it because this server is not connected in the store network, it is connected in the data center network. So switch cannot find this IP in its network. So what the switch will do? So in a situation like switch cannot find the destination, switch will forward that traffic to the default gateway of that network. So here the default gateway is the interface 1 of the router 1, which is 10.1.1.1. So the default gateway means it is an entry or exit point of any network. That means if any traffic is going out of this network, it must pass through the default gateway. If any traffic coming into the network, it must come through the default gateway. Basically, it is functioning as a door to the network. Any traffic going in and out, it must pass through that door. That means the default gateway. So here the router receive that data and it is looking to the data. So from the data, it can understand the destination of this data is 10.1.50.100. So router look into its routing table. Here, same like the network switch manage the MAC address using its MAC address table, router manage its network using the routing table. Basically, routing table is a table that contain all the routing network. So the router receive the data and it is looking for the IP address 10.1.50.100. So here router know the IP address of 10.1.2.0 because it is directly connected to its interface. And it also know 10.1.1.0 network that is also directly connected to this router. But the router doesn't know the IP address 10.1.50.100. So in that situation, the router 1 will ask to the router 2 about the destination. Do you know the IP address 10.1.50.100? Then the router 2 will look into its routing table and it can find it has a network 10.1.3.0. It has another network connected 10.1.2.0, but it cannot find 10.1.50.0 network. So router forward that traffic to the router 3 asking, do you know this network or this IP address? Then router 3 check its routing table. So the network 10.1.3.0 is connected to this interface and another network 10.1.50.0, this network is connected to this interface. So the router 3 will say that I have a network that is 10.1.50.0/24. So that means this destination IP address 10.1.50.100, it must be anywhere in that network. So I am going to forward the data into that network. So the router 3 forward the data into the network using this default gateway 10.1.50.1. And when that data reach in the switch 2, what will happen? The switch is maintaining its own MAC address table and it also use the ARP protocol. So with the help of ARP binding, switch can understand I have a MAC address which is binded to 10.1.50.100. That is this MAC address. Then switch will look into its MAC address table to understand at which interface this MAC address is connected. So switch can understand this MAC address is connected to this interface. Maybe this is the port number 10 we can say. So from the MAC address table, switch can understand this device with this MAC address is connected to port number 10. And switch forward that traffic to port number 10 where this server is connected. So the server receive the data and it will look into the IP address. The destination is 10.1.50.100. That is me. So this data is coming to me. And the source IP is 10.1.50.0. That is the client PC IP address. so it can understand from where this data is coming. Then it's look into the destination and source port. So it can understand the destination port is 443. That means the sales application. So server recognize this traffic is coming towards to it, and it also point to the sales application. So it accept the traffic and register the data accordingly. Now what if the server want to send a response? When the server want to send a response, it know the previous data came from the source IP address 10.1.1.50. So the destination to the response, it should go to 10.1.1.50. And also it receive the previous data from the source port 5000. So this time it know the response must go to the port number 5000. And when the PC receive the data at port number 5000, it can understand this is the response coming from his previous request. So here the destination MAC address and source MAC address is not stable in this network communication because it's keep changing. It keep changing from network to network. In the store network, when the data is transferring, the destination MAC address will be the MAC address of the default gateway of this router, and source MAC address will be the MAC address of the client PC. And when the data pass the store network and when reach in the service provider network, here the source MAC address will be the MAC address of this interface of the router, and the destination MAC address will be the MAC address of this interface of the router 2. And when it pass that network and reach to the next network, the destination MAC address will be this interface MAC address of the router 3, and the source MAC address will be this interface MAC address of the router 2. And when the data enter to the data center network, the destination MAC address will be the MAC address of this server, and the source MAC address will be the MAC address of the default gateway, that is this interface of the router 3. So in a network communication, destination IP address and source IP address stay as it is, but the destination MAC address and source MAC address, it keep changing when the data transfer from one network to another network. So this is the basic working principle of a network. We have explained this data communication scenario with the help of OSI layer. So this is happening in a network, and a network engineer, he must learn the working scenario of a computer network from 0 to 100. That is very essential for a network engineer to design, implement and troubleshoot a network. So in this chapter, we have discussed about how a computer network actually works. Thank you very much for watching, and subscribe to the channel for more videos.